So now that I've written this code, I want to run it on a bigger data set just to see if it works or if something weird happens. So recall that we use small events .csv as our test because it doesn't take long. So now let's switch over to high school. So this is called total events high school. So this is a little bigger of a file. So let's see what happens. See how long it takes to run. Okay, it takes about a second or so, but okay, it's still done. So notice how we have the counts. There's a lot more different types and there's a lot of counts here, but it's okay. It still runs. It only took a few seconds, so let's time it. The high school one's the smallest of the 3 data sets. It took about 1.5 seconds. So now let's do college, which is slightly bigger. So many seconds it takes. I just want to get a ballpark figure of the performance so we can know how long we should expect. This takes about 7 seconds. It's not bad. And we get all the stuff out. And then let's do open, which is all of them. And this should take a little longer. And notice how the assertion still works, which is nice because this guards all these asserts, make sure that we have everything in order and that the number of elements in these dictionaries are self-consistent. This will probably take quite a while longer, maybe a minute or so. So we have to remind ourselves not to crank it open too much. So now I want to actually chain together the open files. I think I can do this. I want to open multiple files and treat them as one stream. Oh, itertools chain, did that work? Because then I can actually use the same code. Can I do that? Itertools chain. Oh, file input, great, cool. Stack Overflow comes right to you. So this actually file input can feed me multiple files at once, and then we can pass it into the reader. I think this will work. Okay, this took about 51 seconds, about a minute. Okay, it's understandable. Okay, so we definitely want to cache this result as a pickle once we are done with it. Okay, let's switch back to high school. Again, this only took 1 second. Okay, so I want to now actually read all 3 files at once so we can do this. So when we can do this, we could just copy and paste the code, but that seems disappointing. So let's actually let's just copy paste just to keep things simpler because I want to check to make sure we don't have any duplicate user IDs. So I'm actually going to do some copy and pasting, which looks gross, but I want to do a sanity check. So I'm going to do high school first, then college. I want to make sure that the SID isn't already in here. No, it's fine. Well, let's not have this check. Let's just use file input. So what does file input do? This gives us kind of a multiple files chained together. So for line in file input dot input. Can't be used as a context manager. No, let's actually not do this. We can't really do this because we have 3 CSV files that need to all have headers. Okay, let's just copy and paste, which is not nice, but it'll do for now because we only have 3. So let's do high school and college. Let's just do both of them together and see what happens. Just make sure there's no error, and then we'll add the open in the end. Now this should accumulate both sets of events. Good, about 8.9 seconds, which makes sense. And I just want to make sure it accumulated. So let's print nrec. So this should be equal to the number of high school records plus the number of college records, just so I can have a sanity check. Okay, so this looks about reasonable. What does this number mean? This is a 1118721. So let's remember this number somewhere. And if we do a word count on all the CSVs, notice how it adds up, right? Because this is high school and college. Just add these two and see what happens. So we're gonna add the college value to the high school. This is how many entries there are in each. And this is right, because if we minus this, we have this number and we minus this, we get 2, because 2 is the number of headers, right? There's one row, one line in the high school header and one line in the college header. So it's actually right. Let's just do one more sanity check. Let's now actually load the open ones in as well. So again, we're going to copy and paste, which is bad, but we're only doing it twice. So let's do open. And this should be very big now. I'm going to run, and this should probably take a minute or so. So we're going to tweak our code while it takes a minute. What I want to do now is I want to actually save this counter away, because once we run it, it takes a minute every time. I want to try to do analysis on it. So we're going to, for this, we're going to use the pickle class, or cpickle, for better performance. And what cpickle gives you the ability to do is to actually stash away a data structure as a persistent file. So we'll call this pair counts.pickle. Write. We need to actually write to it. I think this is the order. So what this does is it actually dumps this data structure, pair counts, into a pair counts.pickle file. So that next time we can just load it. So okay, so it's getting there. 6.8 million, 6834244. So I think it's going to be right. It's still going through the counts. Good, it's going. And all right, about a minute and 2 seconds. Good. So recall that the value for nrex, the printout, was, oh, I missed. It was this big number right here, 6.8 million. I just want to make sure it's the sum of all the CSVs. That looks about right. So we have the college one, 918, high school one, 199, the big open one, 571 something. Add all those up, we get about 6.8 million. If we minus this figure of the total records we get, we should get 3. Okay, perfect. 3 means there are 3 lines as special headers in the CSV that we cut off. 1 header line for each file. Okay, so this looks sane to me, which is good. So what we can do now is we can run it again, and hopefully the pickle file will now be written, will be dumped. So I'm going to check cpickle dump just to make sure it's the right order. Yep, looks good. Pickle dump, open, right. I guess it uses the binary mode, but let's just hope it works. I think you can write the pickle using a more efficient format as well, but let's just use the default format. I'm curious to see how big the pickle file is. And now that we've generated the pickle file, we can do all sorts of data analysis on it that we want, because then we don't have to reparse all the CSV files. Okay, it's going, and let's wait a little bit for it to finish. The worst thing that happens is it runs to the very end and then the dump fails because I mistyped the parameter or something, but hopefully it doesn't happen. Okay, good. It finished in about a minute. So now let's do ls-l here. There's too many columns. But if we do, there's a pickle, pair counts. It's only 3.4K, so ls, there's pair counts.pickle. So, yep, it's 3.4K, so it's tiny, so it's not bad. So now the question is, how do we actually use it? So the output here, pair counts.pickle. If you're curious about what's inside a pickle, you can go into it. It's actually just in some kind of domain-specific stack-like language. We could have gone to a compressed pickle format, but this is the uncompressed format. Anyway, so we produced the pickle file. Great. So now we've actually parsed, what do? We parsed all the CSV data into a nice pair counts pickle file with a count for every pair. So we're going to do the second half, which is to write an analysis script to analyze pair counts.pickle now that we've gotten it.